Okay, so I'd like to show you a few examples. And these are just a couple of things that I picked up around my house. One of them is this flashlight. And this is a human-powered flashlight. It has no batteries. And so I want to put it under the dock camera so you can get a better look at what's going on here. Okay, so here you can see this flashlight. And the reason I bought this one is because it's clear. So you can see what's going on inside. And if you take a look, what is inside? Well, I have a coil of wire, okay, a solenoid, and I have a bar magnet. So when I tilt this, the bar magnet travels through the solenoid, and I tilt it back, and it travels back through. So based on what we just saw, we know that this should be creating some current. And there's also a little capacitor in here, so that's another thing that you guys have learned in this course. And that capacitor is storing this electrical energy that's being created when this magnet passes back and forth through the wire. Okay, so let's see if this thing works. So I've got the switch on, turned to the on position, so we'll know as soon as current is created. You're seeing some reflections here, but there is no light coming out of the flashlight right now. But as soon as I shake it so that the magnet moves, it creates light, okay? And again, I'm only getting electrical energy when I'm putting mechanical energy into it. Now, if I were to turn this off and shake it for a while, then the energy would be stored in the capacitor, and then I could turn this on and have a flashlight. But as you know from experience, when you made your own capacitors, they don't hold charge very long. So this is, you know, this is a piece of survival equipment. But I hope I never have to use something like this because this is a lot of work to do this in order to have light. A slightly better example is this. It's a hand crank radio. So this is another survival tool, but it's useful if you have a power outage and you don't have any candles or any other source of light, no batteries. And what you do here is, again, it's a human-powered electric generator. So it has a crank in the back, and you turn the crank. And as you turn the crank, you are turning a magnet inside of here. Now this one's not clear, so we can't see what's going on inside, but we know that there's a magnet in here. And when I turn this crank, I'm making the magnet spin, okay? And I didn't mention this before, but making the magnet spin is just as good as making the magnet move back and forth. Okay, as long as the magnet has some kinetic energy, then we can get a current by moving it around. And the hand crank example uses a little bit of mechanical advantage, right? A lever, and so we can crank this thing pretty fast. And this is still work, right? Because I'm providing the mechanical energy in order to get the electrical energy out of it, but it's less work than the flashlight that I had to shake. Okay, so let's try this out. I'm gonna turn the crank, and I'm gonna give it a good turn here, generate some electricity. There's a red light showing me that it's charging the capacitor inside, okay? And now I'm going to press the power button, and I have a pretty good flashlight now. So this one works a lot better than you can see it's already fading a little bit. This one works a lot better than the shake version. And this is a radio as well. So let me turn it on. And I've got it on weather radio right now. So let's turn the crank. Just static right now.
Highs in the lower
There we go.
80s. Partly cloudy. Lows around 60. Highs in the mid 80s. Tuesday night, mostly cloudy.
Right, so
Lows in the mid.
Hand crank radio uses electromagnetic induction. All right, now I'd like to show you a few more everyday examples of electromagnetic induction. The first one I'm going to show you is a wind turbine. Okay, so if you've done any driving in Texas, especially in West Texas or along the Gulf Coast, you've seen this. These wind farms where they have these massive wind turbines and the wind is turning them. And these things are producing electricity. And so the question is how? How does wind get converted into electricity? All right, so let's take a look inside of a wind turbine. So this is a schematic, kind of a cartoon schematic of the inside of a wind turbine. Here we have the blades, which are turned by the wind blowing across them. And as those turn, they turn this gear. And then this gear is connected to a generator. And so what is this gear doing when it turns the generator? What's going on inside the generator? Well, there's a electromagnetic induction coil in here with a magnet. And so when the wind turns the wind turbine, the reason that it's producing electricity is because it is turning a magnet. And this is using electromagnetic induction. Okay, here's another diagram with a cartoon schematic. This is a hydroelectric dam. And so how does a hydroelectric dam produce electricity? Well, you have water on one side of the dam, and you allow the water to run through the dam. And as it goes through the dam, it turns a turbine here as the water passes through the turbine. It's very similar to a wind turbine. And what does that turbine do? It rotates a magnet that's inside of a coil. And then that is what produces the electricity. Okay, and here's another example. Even a coal power plant it uses a generator. That is, it turns a magnet. How does a coal power plant turn a magnet? Well, what they do is they burn the coal, and the coal evaporates water and turns it into steam. So here they've got water going through this pipe. The burning coal turns this water into steam, and you get this high pressure steam coming through here, which turns this turbine, and that turbine turns a magnet inside of a coil. And then that water condenses and gets reused. So it's a closed system. So the water keeps getting reused. And so even a coal power plant is turning a magnet, in this case by boiling water. And this is also how a nuclear power plant works, except instead of burning coal, you are splitting atoms, okay? But that produces a lot of energy. That energy is used to boil water and create steam, which turns a turbine, which turns a magnet inside of a coil. Okay, so I hope I have highlighted the importance of electromagnetic induction in our daily lives. It is the way that we produce electricity to power all of the technology that we have, including this computer that I'm using to record these videos and send them to you. Everything comes from turning a magnet, and that holds for wind power, for coal power, nuclear power, hydroelectric power, tidal power. In every case, it is turning mechanical energy into electrical energy using electromagnetic induction. One of the prime exceptions that comes to my mind is solar power. Solar power does not use a magnet. It does not turn a magnet. It's using a completely different principle from physics, which is not something that we'll be able to get to this semester, unfortunately. But it's a very interesting topic. It's called the photoelectric effect. One last thing I want to point out is that in all these cases, we were turning a magnet, and as you saw in my demo in the previous video, you get an alternating current, and that's unavoidable. In order for the magnet to go in a circle, or in order for it to go back and forth, you get this repeating pattern, and so it has to go both directions, and so you end up with an alternating current in every case. And that is one very big reason why we use alternating current in all of our homes, is because that electricity was produced using electromagnetic induction, and that creates an alternating current. We haven't talked a lot about alternating current in this class. We'll talk about it a little bit more. When we get to the end of this chapter, we'll see another reason why alternating current is useful for everyday use. And just so that you know, the batteries and so on that we've been using this semester so far are, they produce direct current, which is to say current that doesn't switch directions back and forth. So that's distinctly different from alternating current that we get from our outlets, which comes from generators of various kinds, all of which have one thing in common, which is turning a magnet inside of a coil to use electromagnetic induction to produce electric energy.